Calc students, Mr. H here, continuing on with our Chapter 3 test review. This is video 2 of 3. In this section, we are going to look at problems 5 through 20. All of these problems are pretty similar in that they're working with logarithmic properties or solving. All right. As we get into this section, one thing hopefully you noticed in the directions of your review, and that's important for me to remind you, is that your Chapter 3 test will be in two sections. There will be a non-calculator and a calculator part. The non-calculator part you will take first. That will involve the graphing problems that we worked in the first video, and then also some of the problems from this video as well. And so anything without an asterisk, I expect you to be able to do without a calculator. Any problem that you see with an asterisk, that will be on the calculator portion of the test. As you get ready for your test, you want to time things out well. And so just as you kind of think ahead, your goal should be to finish the non-calculator part of the test in about 30 minutes and the calculator portion of the test in about 15 minutes. All right. And if you do that, that gives you 45 minutes to take your test. That's kind of the timing expectation. Both sections will be one page front and back. And so again, about 30 minutes for the non-calculator part, about 15 minutes for the calculator part. All right, let's jump in. This video will be a little bit longer because we got a lot more problems to work through it, but we'll get rolling, all right? So the first thing that we want to review here is using our properties of logarithms to expand or condense. So we take a look at problem number 5, right? It is already in its condensed form, so we want to expand this out. As I take a look at this problem, I can see that there are 3 parts to my value, right? I have a 3, I have an x, and I have a y cubed. So I'm going to end up with 3 logarithms in the end here. So as I expand this out, I'm going to end up with log of 3. Now, because the operation between the 3 and x is multiplication, right? It's an addition sign. And then log of x. And then again, the operation between x and y cubed is an addition sign because of the multiplication. And then since I do have this exponent, right, I can use my power property and move that out front. So we end up with 3 log of y, all right? And so this would be the expanded form of our logarithmic expression, all right? We move on to number 6, talking about condensing. Again, as I take a look, I got a couple of logarithms here. Notice that I have some coefficients out in front of those logarithms. So again, I'm going to use my power property to rewrite those as exponents. And so if we kind of take it part by part here, the logarithm is natural log. We're going to condense this down to a single natural logarithm function. So we end up with 4. Again, because of the power property, I can write that as 4 squared all over my quantity of z plus 4. That is going down in the denominator because of the subtraction sign, right? That coefficient is 3 by the power property gets moved to an exponent. And then I can simplify this down a little bit further because I know that 4 squared is 16, so I really end up with the natural log of 16 times the quantity z plus 4 cubed, all right? And that is our condensed logarithm. All right. A couple more of these problems. These should be some problems that you expect to get correct on the test. So again, be prepared for those. We want to get those easy problems, those easy points, all right? So if we take number 7, right, again, this is going to be an expansion problem because of just a single logarithm, right? I've got 2 kind of parts to this, right? I have x squared times the square root of 3x plus 1, right? So I'm going to end up with 3 logarithms in this. I'm going to end up with log base 3 of x squared, and then plus, now, let's stop and think about a square root, right? I can take this statement here, and I could rewrite this as 3x plus 1 to the 1/2 power as we think about what we know about exponents. And because I can write that with an exponent, right, I can move that out front because of my power property as a coefficient. So plus 1/2 log base 3 of the quantity 3x plus 1. So that would be the expanded statement that we have for this logarithmic expression. All right, going on to my next one. All right, first thing I'm going to do here is I'm actually going to simplify this down, right? Because I have the natural log of x plus 2, 2 times the natural log of x plus 2 plus the natural log of x plus 2, right? Like these are like terms. So I can just rewrite that to be 3 natural log of x plus 2. All right, so let's go ahead and combine those together first, then minus 6 natural log of x. And so now again, condensing this down, my power property, right? This is going to become the natural log of x plus 2 to the third power, and then all divided by, because of the subtraction sign, x to the sixth power. And that's as simple as I can go. So there's my expansion and condensing. All right, again, these are properties that will be on the non-calculator part of the test because notice none of those had asterisks. All right, let's move on to solving. This is where we'll start to see some asterisk problems, so just keep a lookout for those. All right, so let's start out with number 9. As we think about solving equations, right, we always want to look for opportunities to use our one-to-one property. I could rewrite this problem as a logarithm, but to me, the easiest thing to do here is just use that one-to-one property, right? Because I can take 4x plus 3, and I know that 16 is the same thing as 4 squared. So remember, my one-to-one property says if I have the same base, right, I can basically just ignore those. So I just end up with x plus 3 equals 2. And then subtract 3 from both sides, so x is going to equal a negative 1, right? And there's my solution. All right, next one, 10, really easy again. One-to-one property, I take a look at both sides of the equal sign. They both have the same base, so I'm going to ignore those. That's going to give me 3x minus 2 is equal to 4. Add 2 to both sides, so I get 3x is equal to 6. Divide both sides by 3, so x is equal to 2. All right. Now, any problem that involves the one-to-one property, again, is a problem that you do not want to miss. That should be some easy points on your test. All right. So look for opportunities to use that one-to-one property. All right. So let's move on. Next couple of problems. Number 11. As we look here again, hey, one-to-one property. Digging this. All right. So x squared plus 1 is equal to 2x. All right, I need to recognize that this has quadratic tendencies here, so let's go ahead and move the 2x to the other side, get it set equal to 0, so we get x squared minus 2x plus 1 is equal to 0, and then I can factor this, so I get x minus 1 times x minus 1, right, and as I set, basically it's the same solution, x minus 1 equal to 0, x is going to equal 1, right, so pretty easy. Just take advantage again of that one-to-one property. All right, number 12, again, another one-to-one property, this time with logarithms. Our first 3 have all involved exponents, but both sides have log base 2, so I basically get to ignore those. So we get x squared minus 3 is equal to 13. Add 3 to both sides, x squared equals 16. Take the square root of both sides, and x is going to equal positive or negative 4. So pretty simple again. All right. All right, continuing on. So again, one-to-one property. We want to be on top of those. All right. 13 and 14 here. Again, number 13. Hey, natural log, both sides, right? One-to-one property. I get to ignore those. So just gives me x minus 2 is equal to 4. Add 2 to both sides, so x is going to equal 6. All right. All right, 14. Now, first off, notice this problem has an asterisk. So this type of problem is going to be on the calculator part of your test. So keep that in mind. All right. Just like we've done throughout class, we are going to solve this completely algebraically first, and the very last thing we're going to do is type this into our calculator. So recognizing that at some point I'm going to want to convert this into logarithmic form, but I need to divide by 27 first, so we're going to end up with e to the 3x minus 2 power is equal to 560 divided by 27. All right, now I can switch it into Logarithmic form, since this is a base e, right, we're going to end up with 3x minus 2 is equal to the natural log of 560 divided by 27. And then I'm going to add 2 to both sides, so we end up with 3x is equal to the natural log of 560 divided by 27. Adding 2 to both sides. And last but not least, we want to divide by 3, so x is going to equal the natural log of 560 divided by 27 plus 2, and all of this quantity is divided by 3, all right? Now, I'm not going to pull up my calculator. I'm going to trust at this point we've done enough examples. You can do this on your calculator. If not, ask a friend for help, and or just type it in exactly as you see it ultimately. Type in the numerator, the parentheses and everything, hit equals, divide by 3, pretty simple. But if we do that work, we should end up with 1.677, all right? Again, calculator part of the test. All right, moving on. Problems 15 and 16. Notice both of these problems are asterisk problems. So again, use your calculator, but we got to solve things algebraically first. So on number 15, first thing we're going to do, divide both sides by 30. When I do that, that's going to give me 8 to the x power is equal to 6. All right. And then I just need to change this into logarithmic form. So x is equal to log base 8 of 6. And now we just need to type this into our calculator, right? If you've got the newer model of TI-84, you've got the log-base function built into your calculator. If not, you are going to need to use the change of base theorem, right, which we would type in as log of 6 divided by log of 8, or you could use natural log, right? Doesn't matter which logarithm you use, but that's what you're going to type in your calculator. If you do that work correctly, you're going to end up with x is equal to 0.862, all right? Hopefully we're feeling good about this test. I think every problem so far is very, very doable, but let's continue on. All right, number 16, again, asterisk problem, calculator part of the test. Take a look. First thing we're going to do, I want to switch this into exponential form, so that's going to give me the square root of x minus 1 is equal to e to the second power. Now I'm going to need to square both sides so I can get rid of this radical sign, right? So that's going to give me x minus 1, e squared, quantity squared is e to the fourth power. And then I'll add 1 to both sides. X equals e to the fourth power plus 1. Type that into your calculator, right? And we should end up with x is equal to 55.598. All right. Again, asterisk calculator part of the test. All right, continuing on, problem 17 and 18. Again, looking for opportunities to switch from logarithmic to exponential form here, but I got to do a little algebra first. So the first thing that we're going to do on number 17 is that we're going to subtract 3 from both sides. So if we subtract 3 from both sides, we are going to end up with 7 from both sides. 6 times log base 5 of x is going to equal negative 3. Then we're going to divide both sides by 6. So we're going to get log base 5 of x is equal to a negative 1/2 when we simplify that down. And then we'll switch it into exponential form. So we're going to end up with x is equal to 5 to the negative 1/2 power. Right? Use the exponent button on your calculator, so we can type that in pretty easily, right? Or you could just recognize, hey, this is a square root of 1/5, and you can type it in that way. Either way, if you type things in correctly, you should end up with x is equal to 0.447. All right. Moving on to number 18. All right. Take a look here. We have 2 logarithmic statements that are being added. What we like to see here is that they both have the same base. They're both common logs. So I can use my properties of logarithms to condense this down. So we're going to end up with log of x times x minus 15 is equal to 2. Now I'm going to switch it into exponential form, right? Remember my base here is 10, so we end up with x times x minus 15 is equal to 10 to the second power. Right, now let's go ahead and kind of distribute my x, and I'll kind of move some things around here, right? So we end up with x squared minus 15x when we distribute the x. Again, recognize some quadratic tendencies here. So 10 squared is 100. I'm going to move that to the other side and set this equal to 0. And now I can solve this by factoring. If you're not any good at factoring, you could use a quadratic formula, but factoring is pretty easy here. So we're going to end up with x minus 20 and x plus 5 is equal to 0. All right, set each of these equal to 0. So x minus 20 equals 0, x plus 5 equals 0. I don't know why I'm doing this part of the work, but just to help those of you out who just might like to listen to me and watch me write. All right, so we get two solutions here, x equals 20 and x equals negative 5. However, important for us to look back, right? If I plug in a negative 5 for x into either statement here, right, I end up with log of a negative value. If you typed log of negative 5 into your graphing calculator, it's going to give you an error message. And we should recognize, right, remember the domain of the parent function for log is 0 to infinity. We cannot put negative values in to that value position. So this is not a solution. Our only solution is x equals 20. All right, moving on to number 19. Everything so far has been really pretty straightforward. 19 is probably the trickiest of our problems. So if we just get started with it, right? So we take a look here, can't use the one-to-one property because we have different bases, right? So if I have different bases, I'm just going to apply a logarithm. And in this case, I want to take the natural log of both sides, because if I do that, right, the natural log of e to the 1 minus x power, right, well, natural log and e are inverse operations, right? So they are going to ultimately cancel each other out. So we just end up with the natural log of 2 to the x plus 1 power equals 1 minus x. All right. And now I can apply my power property, right? We have x plus 1 in the exponent form in front of, or attached to this logarithmic statement, so I move that out front. And so I end up with x plus 1 times the natural log of 2 is equal to 1 minus x. And so now I need to, again, get x by itself. So I'm going to go ahead and distribute this natural log of 2 through my parentheses. So I'm going to end up with x times natural log of 2 plus the natural log of 2 is equal to 1 minus x. And now let's get all of our x values on the same side. And so I'm going to end up with x natural log of 2 add x is equal to 1. And I'm going to take this natural log of 2, move it to the other side. I'm going to do all of my algebra work first, type it in my calculator at the very last moment. So here I'm going to factor out an x because I have two terms, right? They both have x in them. So that's going to leave me with the natural log of 2 plus 1 is equal to 1 minus the natural log of 2. All right, again, this is the most challenging problem in the solving section. Be prepared for one trickier one, all right? If you look back on your quiz, you had one that involved factoring, right? As we thought about that with the exponential value, so good things to be aware of. All right, but let's finish it out. So solving for it algebraically, we end up with 1 minus the natural log of 2, all divided by natural log of 2 plus 1. Again, notice this is an asterisk problem, so go ahead and type that into your calculator. If you type things incorrectly, you should end up with x is equal to 0.181. All right, that brings us to problem number 20, the last one in this section. All right, flip to page 3 of your test review, and here we're just asking you to communicate your reasoning and understanding using proper math terminology. So Here it says, write 2 or 3 sentences stating the general guidelines that you follow in solving A, exponential functions, and B, logarithmic functions. All right. There's lots of different answers you could give here, right? So as I think about solving exponential functions, right, I'm going to look for the opportunity to use the one-to-one property. I'm going to oftentimes switch it to a logarithmic form. Right? There's a couple of sentences about solving exponential functions, right? For logarithmic functions, it's really pretty simple, right? I'm looking for opportunities to use the one-to-one property. Ooh, I didn't finish that up here, right? I could also talk about how sometimes I'm going to have to condense with my properties. But ultimately, we're switching to exponential form in a logarithmic problem. Okay? So those are kind of some thought processes if you watch back through this video on problems 9 through 19. That's really what we did is one of those 5 things that we just wrote down here. All right, that brings us to the end of this review video. The next video will include the rest of your review. All right, good work, people.